Hello class, I am Mr. Sutton, and today we are going to be talking about parallel, perpendicular, and skew lines. So first we have parallel lines. Our definition for parallel lines, make sure you write this down in your notes. Lines on the same plane, so they are coplanar, that never intersect and are always the same distance apart. So this is what parallel lines look like. Think railroad tracks. So we have line A is parallel to line B, and we notate that in our pictures using these arrows. That's how I know, looking at this picture, that for sure these are parallel. If you do not see these arrows, you cannot assume that the lines are parallel, even though it looks like they're parallel. They might be slightly facing towards each other, so that maybe down the road somewhere they do intersect. But if you see these arrows, then you know that they are parallel. They always stay the same distance apart. And another notation we use, so we use the arrows, and we would also say line A is parallel to line B. So if you don't see the arrows, but you see this off to the side, then you also know that this line is parallel to this line. So make sure you draw yourself a picture like this and include this notation that I have here for parallel lines. All right, let's go ahead and talk about perpendicular lines. So the definition I have here for perpendicular lines are lines that intersect to form right angles, and these are also coplanar. That's not part of the definition, but I think it's worth noting that these are coplanar. If they intersect, then they have to be coplanar, right? They have to share a common plane in order to touch each other. So this is what a drawing of perpendicular lines would look like, and we know that they're perpendicular because we have this box here, this square. That's to show that these are right angles. So if you see two lines intersecting that look like they're perpendicular, you don't know for sure unless it says it has this box here in one of the corners. And because of what we know about vertical angles and linear pairs, if I know that this right here is 90 degrees, then that means I know this vertical angle over here is 90 degrees, right? And if I know that this is 90 degrees, since these have to add up to 180, that means this also has to be 90 degrees, and this also has to be 90 degrees. So if you know one of the angles is 90 degrees, then you actually know that all of them are 90 degrees if it's an intersection like this. And the other notation we use in writing, so this is something you would use in like a proof, A is perpendicular to B. So if you see two lines intersecting, it looks like they're perpendicular, but it doesn't have this box, but then maybe in the given section, it tells you A is perpendicular to B, then we know, yes, these are perpendicular. So make sure you have this definition written down as well as this picture and this notation for perpendicular lines. Now, let's go ahead and take a look at skew lines. So skew lines is probably the one that we are least familiar with going into this. So the definition for skew lines is lines that are not coplanar. So the other two were coplanar. Perpendicular lines were coplanar and parallel lines were coplanar. So this means that they do not intersect. They cannot intersect if they're not coplanar, and they are not parallel. So parallel lines don't intersect, but parallel lines are coplanar. Skew lines are not coplanar, they do not intersect, and they're not parallel. So let's go ahead and draw a picture of what this looks like. So to visualize skew lines, because they are not coplanar, you really have to think in 3 dimensions. So I think the best way to do that is to think about them existing on a 3-dimensional shape. So I drew a cube here, and we can see this red line on this top edge will not intersect with this blue line on this side edge, right? We can see that they definitely will not intersect. If you think about a cube, if you extend those edges, they do not intersect, and they are not in the same plane. They do not share a common face of this cube, and I cannot draw in a common plane that they would share. So these are skew lines. Another way you might see skew lines drawn, for example, is so I have this plane Z here, and then I have this line which exists on that plane, and then I have this other line which is only passing through this plane at this one point here. So clearly they did not, the lines themselves don't share the same plane, and they do not intersect because this line only passes through this plane at one point, and at that point it is not intersecting with that line. So that is another way you'll see skew lines illustrated. There is no other notation that we use for skew lines, so there's no like statement I could write out which has a symbol for skew lines. You would just have to say that something like lines A and B are skew. And probably the reason why there's no notation for skew lines is because they are not useful for us for proof purposes, but it is important to be able to identify when lines are skew. All right, make sure you have this definition written down as well as both of these pictures in your notes. And this is a pretty short lesson today. That's all I have for today. So make sure you have all of this stuff written down in your notes. If you have me in class, I'll see you in class. If you have any questions about this stuff, make sure you're signing up for office hours and have a good day.